Hello everyone, in this video we will answer together the Cambridge International ASN A-Level paper for Mathematics, Paper 5 Probability and Statistics 1. The code of this paper is 9709/52 from the October-November 2023 series. First of all, let me introduce myself. My name is Michelle, I'm from grade 11C, and along with me in this video is Fiorin and Vanessa. I will explain the first three numbers and they will continue with the rest of the numbers. So let's go on to the first question. A competitor in a throwing event has 3 attempts to throw a ball as far as possible. The random variable x denotes the number of throws that exceeds 30 meters. The probability distribution table for x is shown below. So there are 4 values of x which are 0, 1, 2, 3. And the probability of each of these values are 0.4, p, r, and 0.5, respectively. So A, given that ex equals to 1.1, or the expectation of x equals to 1.1, find the value of p and the value of r. So here we are given the expectation of x, which is 1.1, and we know that the formula of expectation of x is the sum of the value of x times the probability. So here we have 0 times 0.4 plus 1 times p plus 2 times r plus 3.0.15. We can get all these values from the table here, so you just have to copy the values. And that all will be equal to 1.1. So we can simplify this equation by adding up 0 plus p plus 2r plus 0.45. And we can further simplify that equation to p plus 2r equals to 1.1 minus 0.45. So here we move the 0.5 to the other side. So 0.5 becomes minus 0.45. And now we have our first equation, which we will use to, we will find 2 equations to get the values of p and r to eliminate them. So the first equation is p plus 2r equals to 0.65. Now to find our second equation, we can use the fact that the sum of all the probabilities will be equals to 1. So we can just add up the probabilities, which are 0.4, p, r, and 0.5. That would all be equal to 1. So we can simplify the equation into p plus r equals to 1 minus 0.4 minus 0.15. So here we move the 0.4 and 0.15 to the other side, which makes them negative. And now we have found our second equation, which is p plus r equals to 0.45. So now that we have our 2 equations, we can eliminate them by subtracting the first equation to the second equation. You can also use the substitution method, but here I will show the elimination method as I find it easier. So we have p plus 2r equals to 0.65 and p plus r equals to 0.45. Here we're going to subtract them. So p minus p will be equal to 0, so we can just eliminate all the p's. And then 2r minus r equals to r. So we have r here. And then we have 0.65 minus 0.45, which will be equal to 0.2. So here we have our first answer, which is r equals to 0.2. And now we can just take one of the equations that we have before. Here I will take the equation of p plus r equals to 0.45, which is the second equation. So here we just substitute the r with 0.2, which we have found earlier. So p plus 0.2 equals to 4.5. So we can find p by subtracting 0.45 with 0.2, as we have moved the 0.2 to the other side, so it will be negative. So now we know that p equals to 0.25. So here are the 2 answers. The value of p is 0.2 and the value of p is 0.25 and the value of r is 0.2. Now for the next question, B. Find the numerical value of variant of x. So we know that the variant of x equation is the sum of x squared times p minus the expectation of x squared. You can find this in the formula list. So we can just substitute the values that we have earlier in the distribution table. So 0 squared times 0.4 plus 1 squared times 0.25 plus 2 squared times 0.2 plus 3 squared times 0.15 minus 1.1 squared. If we put all of these in the calculator, it will give us the value of 1.19. Moving on to the second question. George has a fair 5-sided spinner with sides labeled 1, 2, 3, 4, 5. He spins the spinner and notes the number on the side on which the spinner lands. A. Find the probability that it takes fewer than 7 spins for George to obtain a 5. So we know the situation is a geometrical distribution because we have we have an infinite number of tries that we can have from, and the probability of success will be 1/5, as we want George to obtain a 5. So here we have 1, 2, 3, 4, 5. So the chances of obtaining a 5 from the fair-sided spinner will be 1/5. So we can find the probability that x is fewer than 7. So we know that probability of x fewer than 7 is equals to the probability of x is less than or equal to 6. So we can find this by subtracting 1 with probability of x is greater than 6. We know that the probability of x greater than n equals to q to the power of n, in which q is 1 minus the probability. So here we have 1 minus 1/5, which is 4/5. Q is the probability of failure, by the way. Yeah, so we can have 1 minus 4/5 to the power of 6. So if we put it in the calculator, the answer we will get is 0.738 and 3 significant figures. Next question. George spun the spinner 10 times. B. Find the probability that he obtains a 5 more than 4 times but fewer than 8 times. So here the situation is now a binomial distribution because we have a fixed number of trials, which is 10. George spins the spinner 10 times, so 10 is the number of trials. And then the probability of success is the same as earlier, 1/5, because here he wants to obtain a 5. So the value of q is the same as 1 minus p, so 1 minus 1/5 equals to 4/5. It's the same as earlier. So here we want to find the probability that x is greater than 4 but less than 8. So here we know that the numbers in between, we want to find the probability that he obtains a 5 for the numbers in between 4 and 8, excluding the 4 and the 8 because there is no equal sign or like so we can find the probability of this by adding up the probabilities of him getting a 5 in 5 tries, 6 tries, or 7 tries. So this will be the probability of x equals to 5 plus the probability of x equals to 6 plus the probability of x equals to 7. So we know that the formula for the probability of x equals to r is n choose r times p to the power of r times q to the power of n minus r. So we can just put all the numbers in the equation. So 10 choose 5 times 1/5 to the power of 5 times 4/5 to the power of 5 plus 10 choose 6 times 1/5 to the power of 6 times 4/5 to the power of 4. And then the last one is plus 10 choose 7 times 1 over 5 to the power of 7 times 4 over 5 to the power of 3. So if we put this in the calculator, it will be 0.02642 plus 5.505 times 10 to the power of negative 3 plus 7.864 times 10 to the power of negative 4, which will result to 0.0327 in 3 significant figures. Now for the third question, a factory produces a certain type of electrical component. It is known that 50% of the components produced are faulty. A random sample of 200 components are chosen. Use an approximation to find the probability that more than 40 of these components are faulty. So we know that this is a binomial distribution, but since they asked us to use an approximation, we will have to change this binomial distribution into a normal distribution. So here we have xb is 200 and 0.15, 200 being the number of trials and 0.15 being the chance of success. In this case, the chance of success is the chance that the components produced are faulty. So yeah, we can transform that into a normal distribution first. So the normal distribution will need like the mean and the variance. So here we can find the mean by multiplying the n and the p, the n being the number of trials and p being the probability of success. So 200 times 0.15 will be 30. And the variance is, we can find that by multiplying the n, the p, and the q. The q is 1 minus p, so 1 minus 0.15, which is equals to 0.85. So we can find the variance, which is to 25.5. And later, if we need the standard deviation, we can just find the square root of 25.5. So here we are asked to find the probability that more than 40 of these components are faulty. So here we can just imagine the normal distribution curve. So we know that the mean is 30, so the middle of this curve will be 30 here. And then we want to find the probability that more than 40 of these components are faulty. So probability that x is greater than 40, so the 40 will be here. But since we're using an approximation from binomial to normal, we have to add or subtract 40 by 0.5. So since there are no equal signs, so the box here will not be included in the probability. So here we can just find the z by subtracting 40.5 minus 30 over the square root of 25.5. So you know the way to find z is by subtracting the value of x with the mean and then the standard deviation. So we will find that the probability of x greater than 40 is the same as the probability of z is greater than 2.079. But since we will be using the normal distribution chart, we have to find the probability that z is less than a value. So you can find that by subtracting 1 with the probability that z is less than 2.079. Then we can find the value from the chart given. So we will find that it is 0.9812. So if you input in the calculator 1 minus 0.9812, we will find that the probability, the final answer will be 0.0188. This is in 3 significant figures.
Hi everyone, my name is Vanessa and I'll be explaining number 4 and 5 for this paper. Number 4. The heights in centimeters of the 11 players in each of two teams, the Aces and the Jets, are shown in the following table. A. Draw a back-to-back stem and leaf diagram to represent this information with the Aces on the left-hand side of the diagram. So first of all, we need to arrange the heights from the lowest to the highest. As in, the key for this one is 1/17/0 means 171 centimeters for the Aces and 170 centimeters for the Jets. So as you can see, for example, the lowest height in the Aces is 164. So this one is 116 and this side is 4. Next, B. Find the median and the interquartile range of the heights of the players in the Aces. So we need to find the position of the median, which is 11 plus 1 over 2 equals to 6. So the 6 number in this back-to-back stem and leaf diagram is 173. So our median is 173 centimeters. Next, we need to find the interquartile range, which is Q3 minus Q1. To find Q1, first of all, we need to find the middle point of the first half, which is 168 centimeters. And for Q3, we need to find the last half of it, which is 181 centimeters. So we need to minus both of them. 181 minus 168 equals to 13 centimeters. Next, for C, give one comment comparing the spread of the heights of the Aces with the spread of the heights of the Jets. One comment is Jets have a wider range of height. It is because the Jets have a greater IQR than the Aces. 5A. The heights of the members of a club are normally distributed with mean 166 centimeters and standard deviation of 10 centimeters. The first A. Find the probability that a randomly chosen member of the club has height less than 170 centimeters. First of all, we need to write that X is normally distributed with a mean of 166 and a variance of 10 square. As you know, the formula for variance is the square root of the standard deviation. Probability X is less than 170 based on the question. So the formula for this one is probability Z is less than 170 minus 166 over 10, which you will find probability Z less than 0.4. And based on the table, 0.4 is right over here. So Z is 0.6554. Next, the second part of the A. Given that 40% of the members have heights greater than 8 centimeters, find the value of H correct to 2 decimal places. So probability Z greater than H, which we need to find, is minus by 166 over 10 equals to 0.4 because of 40%. We change it to decimal. So probability of big Z less than little z is 0.6 because this is greater than. We want to change it to less than. So the probability, the Z which is the closest to 0.6 is this one. So this is 0.2, 0.25, and then we find that 12 is the closest number that can be added to this number that equals to 0.6. So we get 0.253. So we just put h minus 166 over 10 equals to 0.253. You just cross multiply this and this equals to 2.53 equals to h minus 166. We move this to this side. So 166 plus 2.53 is 168.53, which is in 2 decimal places. Next, B. The random variable x is normally distributed with mean mu and standard deviation. Given that 2/3 mu, find the probability that a randomly chosen value of x is positive. So probability x is greater than 0. So probability, because given that the probability is positive, so it has to be greater than 0. If it's less than 0, that means it's negative. So probability z is greater than 0 minus mu over the standard deviation. So you just plug this one in this. U0 minus mu is minus mu, and then you equate it to minus 1.5. And then probability z is greater than minus 1.5 is equal to probability z less than 1.5, because it's exactly the same area as this one. So we can just find it with probability less than 1.5, which is 1.5 and then 0 for this one, and the answer is 0.9332.
Hello everyone, my name is Fiorin, and for the last part of this paper, I will be explaining it. Now, the last part of the paper comprises of numbers 6 and 7, so let's dive into it real quick. Freddy has 2 bags of marbles. Bag X contains 7 red marbles and 3 blue marbles. Bag Y contains 4 red marbles and 1 blue marble. Freddy chooses one of the bags at random. A marble is removed at random from that bag and not replaced. A new red marble is now added to each bag. A second marble is then removed at random from the same bag that the first marble had been removed from. A. Draw a tree diagram to represent this information, showing the probability on each of the branches. This sounds like a lot of information, but let's break it down into simple, understandable bits. So you see here, bag X contains 7 red marbles and 3 blue marbles, which means that the total amount of marbles in bag X would be 10, because 7 plus 3 is 10. Bag Y contains 4 red marbles and 1 blue marble, so 4 plus 1 equals 5. The probability of drawing a red marble from bag X would be 7 out of 10, and the probability of drawing a blue marble would be 3 out of 10. This is because there are 7 red marbles, and the total is 10 red marbles, so we divide 7 by 10. Same goes for blue. Bag Y's probabilities of drawing a red marble would be 4 out of 5, and for the blue marble, 1 out of 5. As you can see below, I've illustrated a tree diagram and color-coded it to help avoid at least some confusion. Now, remember that one of the bags are chosen at random, so you have to include the first bag selections as the probability, so that is why there is a 1/2 over here. The next part over here would be your first selection, or Freddy's first selection of the marbles, and then these are the branching probabilities of the second selection. So you can see here, as we have written down, 7 out of 10 would be the probability of getting a red marble from bag X on the first draw. But then you go to the second draw and wait, why is it 7 out of 10 as well? This is because, remember, a new red marble is now added to each bag. If you take a red marble out of bag X and then you put another red marble into bag X, the probabilities will stay the same. It's like taking a fish out of a tank and then you put the fish back into the tank. Well, a different fish, but the number of fish will stay the same. Let's move on to bag Y. Now, bag Y has something interesting going on for it. When you see the bag Y's double red or red blue selection, you'll notice that yes, the trend remains the same in general. The probabilities will still remain the same if red is your first draw, but when you go to the blue first draw, well, the 1 out of 5 changes into a 0 and the 4 out of 5 changes into a 5 out of 5. Well, this is because if you take a blue marble out of the bag, it won't be replaced because it's only the red marble that gets added back in. So you go from 4 red marbles to 5 red marbles, and the only color you can get from bag Y, the only color of marble, after your first draw would be red. So there is a 5 out of 5 probability, or 1, to get a red marble on your second draw if you first draw blue. Let's move on to B. Find the probability that both of the marbles removed from the bag are the same color. Now, there are 2 possibilities that we can have. You first draw a double blue, and the second you draw a double red. Now, remember that the bags are still included in the probabilities, so you'd have in total 4 probabilities. XBB, or bag X blue blue, XRR, bag XRR, red red, YBB, and YRR. Now, as you can see here, I've already put a bunch of fractions over here. You might be a bit confused, where did I suddenly get these fractions from? Now, let's go back to the tree diagram. For example, let's say I took a bag X double blue draw. Now, you multiply 1/2 the probability of selecting bag X, you multiply 3 out of 10, probability of drawing blue, and then 2 out of 10, probability of drawing another blue. So you multiply all these together to calculate the probability of drawing an X double blue. You can also apply the same thing for an X double red, a Y double blue. Well, not really a Y double blue, because remember, anything times 0 will be 0. But you can do the thing for bag Y double red. Once you've crunched the numbers and hopefully your calculator does not have a character limit, it will be 109 per 200, or 0.595 to 3 significant figures. C. Find the probability that bag Y is chosen given that the marbles removed are not both the same color. Oh, I don't like this question. I actually think that not many people like the given questions. A trick that you can use to make your life easier for the given questions is that when you're forming your phrase, you can always change the line in the middle to become a slash. You will make the Y the numerator, and then you can make the one below over here the denominator. Now remember, the formula for given is always the intersection divided by the second one, the given, the event that comes first. Because given, this says that the different colors have come first. So remember, the right side of the dashed line, this thing, it will always come first chronologically. So you want to divide your intersection by this. Now, remember what we did in B. You look at the tree probability, you calculate all of that stuff, you calculate the intersection, and then you calculate the probability of different colors, you add them all together. And when your calculator hopefully cooperates with you, you will get the 9 per 50 out of 81 per 200, and if push comes to shove, you inputted it all correctly, A simple 4 out of 9 will be your final answer. And finally, 7A, one of my least liked statistics topics, permutations and combinations. Maybe you like it, maybe you don't, but it can be confusing. It's really confusing sometimes to know what the question wants, so you have to read very, very carefully. I cannot emphasize this enough. So let's read through this question together. 7A. Find the number of different arrangements of the 9 letters in the word Andromeda, in which no consonant is next to another consonant. The letters D, M, N, and R are consonants, and the letters A, E, and O are not consonants. Forgive me, I'm still a bit sick. Now, you might see here that I have color-coded the consonants and the non-consonants. V stands for vowels, and vowels are the A, E, I, O, U, and all of that stuff. But since Andromeda has only A, E, and O, we'll only be using vowel as a stand-in for A, E, and O. So, Andromeda, you see that I've highlighted the A's and the D's. You may be wondering why. Well, that's because they are duplicate letters. We want different arrangements, and the duplicate letters, switching around the positions of the duplicate letters wouldn't really be a different arrangement because A and D are identical. So that is why we divide 5 factorial times 4 factorial by 2 factorial times 2 factorial. You may be wondering where I got the 5 factorial by, or the 5 exclamation mark and the 4 exclamation mark. Well, it's because refer back to this dashed line over here. Because you see here, there's 5 consonants in total. 1, 2, 3, 4, 5. 5 consonants. And then you can swap them freely in like goodness knows how many arrangements. For the vowels, you can also go swap them around freely, but remember, no consonant is allowed to be next to another consonant, which means that they have to have a gap of at least one vowel in between. So, although you can swap freely, remember that rule. So, the 5 factorial times 4 factorial will have to be divided by 2 factorial times 2 factorial, and when you calculate that, you will get 720 as your final answer. B. Find the number of different arrangements of the 9 letters in the word Andromeda in which there is an A at each end and these are not together. Now, this question might seem a bit tricky, so let me give you a brief pancake analogy. Say you have burnt, like, for some reason, a quarter of your pancake. Oh no, that part's inedible, unless I guess you like eating burnt pancakes. But that aside, you have burnt a quarter of your pancake, and now you're sad, so you have to cut out a quarter of your burnt pancake so it will actually be edible. The same logic applies here for my working. The 7 factorial per 2 factorial is the total amount of arrangements with the A's at each end. And the 2 factorial, of course, is for the duplicate letters. And in this case, the duplicate letters will be D. Now, you may be wondering, why didn't I include positions, the positions of A and A over here? Well, that's because they're fixed in place. You can't change them. And about the swapping letters, swapping the A's together, they're the same thing. It wouldn't make a difference. So you have the 7 positions. Well, technically 6, but because I grouped the D's as one unit, remember the pancake analogy? So 7 factorial per 2 factorial, and then you take away 6 factorial. 6 factorial is the amount of arrangements in which the D's are together. And then you'd get 1,800. And finally, we are on page 11 of the past paper. The last letter, I can almost hear you saying, thank goodness that it's almost over. Good job. So here, 4 letters are selected at random from the 9 letters in the word Andromeda. C. Find the probability that this selection contains at least one D and exactly one A. Now, remember, there are only 2 Ds in Andromeda and 2 As in Andromeda, but you can only have exactly 1 A and minimum 1 D. So you can see the dashed lines here. You can make 4 selections, but they have to contain at least 1 D and exactly 1 A. So let's see here. Let's say that you have 1 D in the selection and 1 A in the selection. So 2 choose 1 times 2 choose 1 times 5 choose 2. If you're wondering where I got the 5 from, the 5 is because after you take the 2 Ds and 2 As out, you would be left with 5 letters. So, and you choose 2 of those from the remaining 5 letters. So 2 choose 1 times 2 choose 1 times 5 choose 2, that would be 40. And let's say your second selection over here, you take 1 D, take another D, and then you take 1 A. So the rest over here is just free space. So 2 choose 2 times 2 choose 1 times 5 choose 1 equals 10. Now you total them together and you get 50. The total amount of selections that can be made would be 9 choose 4, which is equals to 126. So each out of the 9 letters of Andromeda, you choose 4 of them. The probability of this selection containing at least 1 D and exactly 1 A would be 50 divided by 126, as 50 is the amount of ways that fulfill the requirements and the total amount is 126.